Okay, okay. Can you hear me, Mr. Emmanuel? Good evening, everyone. Good evening, good evening, good evening. My name is Rashid Oguniran. I will be moderating this session. And the topic of our discuss today is on create models by using Azure Machine Learning Designer. This is another series. We've had one on how to update with Excel, and now this data science session. And we are bringing on board another another presenter today by name Emmanuel Eze. Is going to take us through how we can create models by using Azure Machine Learning Designer. Ladies and gentlemen, let's welcome the speaker of today, Mr. Emmanuel Eze. You have the floor, sir.
All right. Thank you, Rashid. And hello, everyone. It's good to be here again. I think the last time I was here, we had quite an interesting session, and this is another part to that essentials to data science, right? But for today, we're going to be talking about how to create models by using Azure Machine Learning Designer, right? Of course, we discussed Azure Machine Learning. We've been discussing Azure Machine Learning, and we've gotten to understand that we could do quite a lot, using Azure Machine Learning. We can build our data science pipelines. We can create our machine learning models, whether using the graphical approach or using the coding approach. But for today's session, we're going to be, streamlining down to using the graphical approach, which is the Azure Machine Learning Designer part of the solution, right? So I'm going to walk us through the outline, what we designed the outline to look like for today's session. We're going to talk about machine learning models, right? Um, After that, we're also going to look at building machine learning models. What are those steps that you take, in order to build a machine learning model? Also, we're going to start looking at building a machine learning model on Azure Machine Learning, right? And that's going to be using the Azure Machine Learning Designer. And of course, there is no way to top this up than to have a hands-on experience. So we're going to be having a demo to look at some of these things that we get to talk about. After which, we would address whatever questions that would stem from the session. Now, without further ado, we've been hearing models, machine learning models. Really, what's a machine learning model? What's a model? Right? So in the context of machine learning, a model, it's basically a computer code that can process information to make predictions or a decision based on the data that you feed into it, right? So basically what we are saying is that a computer code or a computer program that expects you to provide data, and then after you provide the data, it's going to look at patterns. It's going to look at quite a number of behavior within the data, and it's going to make decisions based on that, right? And also, importantly, it's for us to note that a model expects an input in order to provide an output. Um, I can some sound from Mr. Rashid. If you could please mute. I don't know if you're muted. Can you go ahead and mute, please? Thank you. All right, thank you. So just back, apologies for that. So just back to this. Now, I did mention that a model expects you to provide an input, right? And in the context of machine learning, what we're going to be imputing into our model is data. So I want to be able to make a prediction. I want to be able to predict the price of a house. I want to be able to predict whether a customer is going to buy something or not. I want to predict whether an employee is going to exit the organization or not. I want to predict the temperature of Lagos State, right? These are the outputs that I expect my model to provide. but I need to pass something into it. So what do I pass? I need to pass data into my model. I could be passing things like, demographic information. It could be transaction information. At the end of the day, I am passing in something for my model to process and give me something in return, right? So that's basically the concept that we're going to be taking this. We're going to try to keep it as simple as possible so that we can be able to carry everybody along. Now, down to building a model, right? What are the things that we should have in mind, when trying to build a machine learning model or when trying to solve a problem using machine learning, right? First of all, we did say that we're going to be feeding in data into our model, right? So the very first thing that we should start with is even understanding the data that we're dealing with, right? So we can get to have an exploration of our data in a process we call exploratory data analysis, right? So we look at the data, we look at things for that are within the data to see if there are missing values, if there are some kind of preparation that we need to carry out, on the data, right? So that way, in order to get our data ready for the process. So in some cases, you could have data that it's fairly okay to pass into your model. Your exploratory data analysis will tell you if you have data that has quite a number of issues or some issues that you need to fix before passing it into your model. This is where you get to find that out through your exploratory data analysis. Now, after that, we start talking about what we call feature engineering, right? So basically, if you think about the type of data that we want to pass into our machine learning model, it could be three columns, three different fields. You want to pass three different fields into your model so that your model can predict something, right? But then again, there could also be, if you look at the data, when you analyze the data from those three fields, you can be able to get additional features or additional fields in our data science pipeline. We refer to those fields that you get from your data, we refer to them as features, right? So we can be able to derive more features through a process we call feature engineering, right? So that's another key process, when building a machine learning model. After that, we now start asking ourselves, okay, what model do I use for this particular problem that I want to address, right? And if you think back to the last session that we had together, right, we did talk about the fact that in machine learning, we could be trying to address different problems, maybe from anomaly detection to predicting a category or predicting a number or predicting or clustering, basically looking for how different objects are similar and then putting them into buckets, right? So at this point, you have to decide what model you want to use. And there are quite a number of machine learning models. And you have to decide of all of these machine learning models, which one is ideal for me to utilize for this problem I want to solve, right? So the very first thing that would come to your mind for model selection is, what kind of data am I dealing with, right? You have your data, you've done exploratory data analysis, you've done maybe feature engineering, and then you probably look at the data. And the key question to ask is, well, this is one consideration. Is the data, the number of records you have in that data set, is it more than 50 samples, 50 different samples? So let's say, for instance, I'm dealing with employee data. Do I have up to 50 employees in these data sets that I want to use to build my model? Well, ideally, we advise, if you don't have up to 50 samples for building that model, we advise that you go and get more data so that it will be sufficient for the process you want to carry out, right? So, because when you're training your model, you need to train your model with enough observations of data so that it can be able to learn the different possibilities that could happen, within your data set, and then make predictions effectively, right? So the advice, if your data set is less than 50 records, um, you should go get more data. But if it's more than 50 records, right, then you start asking a different question. What are you trying to predict? Are you trying to predict a category? So are you trying to predict a yes or no kind of situation, a churn or not? Or you're trying to predict, are you trying to predict a category, basically, right? Now, if that is what you're trying to predict, whether a customer is going to churn, whether somebody is going to have diabetes or not, or you're predicting between two categories, then if that is the case, if that is not the case, if you're not predicting a category, the next question would be, are you predicting a quantity? Are you predicting a number? Right? So let's say you're predicting a number, there's a different route you take. But if you're predicting a category, then we ask another question. If the data is labeled, right? So if I'm predicting a category, looking at the data set that I have, do I know the possible outcome for each of those occurrences, for each of those data sets that I have, each of the line items in the data sets that I have? For instance, if I see a customer that has um, um, maybe a customer that lives in a particular state X and also has account balance less than 20,000, then there's a possibility that that customer might not transact with me, right? So it means that I have a label that says if I have this condition, then this is the outcome. That is what we refer to as having a labeled data, right? So if I have a picture and then I am putting a name to those images, that's a labeled data, right? So in machine learning, we could have scenarios where we have data that is labeled or data that is not labeled. How we address or how we approach those two scenarios, they are two different things, right? So, but let's continue with the map that we have here. Now, back to whether you're predicting a quantity. If you're predicting a quantity, maybe you're predicting the price of a house, or you're predicting the temperature of a room, or you're predicting maybe stock price, whatever it is, so long as what you're predicting is a number, so long as it's a quantity, right? Then you're talking about a regression kind of problem, right? We did mention this in the last session that we had, but then this is a warm reminder so that we can have this at our fingertips. So if you're predicting a quantity, then yes, it's a regression problem. But then if you're predicting a quantity, if you're predicting if you're not predicting a category and you're not predicting a quantity, perhaps maybe you want to try to do some things like dimensionality reduction. This is a complex aspect, but I'm not going to dive deep into that. But basically, maybe you're trying to do dimensionality reduction so that you can convert a couple of features to help you predict a category or a number, right? So, but these are some of the possibilities that you could have when you're talking about predicting a quantity. But then again, let's go back to predicting a category. If the category is labeled, then you're trying to classify. You're dealing with a classification kind of problem. So you would use models that are designed for classification problem. If you're not predicting, if data is not labeled, but yet you're trying to predict a category, then you're probably talking about clustering, right? So what the machine learning model would get to do is to recognize out of all of these observations, how many of them look like, how many of them are similar. Those of them that are similar, it groups them into a category. It just does that grouping, and that's what we call clustering. Well, at the surface level, that is what we call clustering, right? And yeah, that's basically for model selection, which is another key process that we have to pass through, right? So when you know the type of problem that you're trying to solve, then you know the best model or the type model that you're going to make use of. And take note, for each of these type of problems, whether regression or classification or clustering, for each of those type of problems, there are different models that can be used for those type of problems, right? So for instance, you can have maybe the random forest, you can have the decision tree for the classification type of problems. For the regression, maybe you want to use linear regression. There are quite a number of models that you can use for that particular use case. Now, once we are done selecting our model, the next thing we would get to do is to train our model, right? So we have our data, we've explored the data, we've generated the features that we need to, get the best insights from our data. We've also selected the model that we want to use. Remember, the model is a computer program that expects you to pass data into it, and then it will be able to learn from that, right? So whether it's a labeled data, whether it's a non-labeled data, we would still have to pass the data through our model. Our model begins to learn based on what we pass to it, right? And at the end of the day, we can be able to use that model to make predictions. Now, once we are done training the model, we need to be able to know, is this model performing optimally, right? And another key thing that we need to take note is when we're training the model, in a lot of the standard process is that we don't use the entire data set that we have to train the model. For instance, if I have 10,000 records, if I have 300 records, right? I can split that data into two parts. One part will be used to train the model, another part will be used to evaluate the model. So that way, I can know if my model has learned and is behaving the way I expect it to behave. And what is the way I expect it to behave? I expect when I pass the picture of an apple, it would recognize that this is an apple and not categorize it as a banana, right? If I pass the data of different variables about a room, it should be able to predict to a certain degree of certainty the temperature of that room. So these are what I expect we can be able to use models to do quite a number of other things, but I'm just using those as use cases. When we've trained our model, we need to also evaluate the model to see if it's performing optimally, right? A number of parameters that we get to utilize for evaluating our model could range from accuracy. How accurate is your model, right? Also precision, recall. These are a number of terms that I would advise that you get to read up on, right? Because if we try to go into everything that we're going to be discussing here, trust me, we won't be able to cover it in an hour. But these are some of the parameters that we look out for in evaluating our model. Now, once we are done evaluating our model, we need to deploy that model. So long as the model has performs well enough, right, we can deploy that model so that we the intended process, the intention of the building that model in the first place can be achieved. If we're building the model so that we can use it in our business applications or in one process or the other, then end users can be able to consume that machine learning model from the service that we've deployed. Now, at the end of the day, another key thing to have in mind is monitoring. You need to be able to keep an eye on your model just to make sure that as time goes on, your model keeps performing optimally. If there is need to, then you can, from time to time, retrain your model, using a more recent data that reflects the current times, that you're in. But basically, this is the process, to keep in mind. Now, all of this that I have talked about, right? The essence of going through this is so that when we are talking about Azure machine learning, using the designer or using the notebook approach, you'd understand that it is still the same process that we're going to go through, right? The same cycle that we've talked about, that is what you're going to go through. But then you would have to, depending on which one works better for you, you can choose to use the notebook, you can choose to use the designer. For this session, we're going to keep our attention to the designer, right? And aside from that, another key thing to keep in mind is some of the parameters that we use to, evaluate our model. Some of these could also be some of the errors, because if you think about what we are trying to do, we're trying to um, pass data into our model, train the model so that the model can be able to make predictions. Now, when we are evaluating the model, we are passing the test data without the observations or without the output. We're just passing the variables or the fields that hold the data into the model and let the model give us an answer. When it gives us an answer, we would compare that answer with that answer that we have that we did not show to the model, right? When we do that comparison, we can see how far off is our model. Is our model performing well enough? Is it performing close to what the reality should be? The expected answer that we expect the model to give. What the model gave to us in comparison to the expected answer, how close is it? Now, it's likely not going to be close, it's likely going to be close. If it's not close, that difference between the correct answer and what the answer should be, that is how you measure the error of the model, right? And there are a lot of things that goes into that, but on the screen you would see that there are quite some errors that we can some matrices that we can keep an eye on in order to see how our model performs. Mean absolute error, root mean squared error, relative absolute error, relative squared error, coefficient of determination. These are some terms that we would get, familiar with as we go down the line, right? So, but for this session, I'm not going to go deep into that. In fact, what I'm going to do right now is take us to the Azure machine learning platform, and then we can see how to build our model using the designer, right? Yes, I know some of us are, well, I want to believe that we're actually excited about this. So right now, I will just go ahead and bring up a different screen. Um, just give me a moment. So I will stop sharing my slide and switch to a different screen. Just a moment. Great. So just one moment. So I'm just going to. Okay. So now, if you look at what we have on the screen now, just give me a moment. I think I still have my slide on. I will just reshare. Mr. Rashid, could you confirm you can still see my screen?
I think it's still coming up. I can't see it as at now.
Yeah, can you? I think you may need to add it to the stream. Just see if you can add it to the stream. Oh, great.
Okay,
Thank you.
I think it's up now. It's up now.
Great, great, thanks. Okay, so now
Yeah.
if we direct our attention to the screen, right? Remember, we said all of the magic that we're going to be doing, all of the excitement that we're going to be having, we're going to be doing that on the Azure Machine Learning Studio, right? Of course, we can be able to access that through the Azure portal, which is where I am right now. So once you click on Launch Studio on your Azure Machine Learning instance, it's going to take you to the Azure Machine Learning Studio, right? So for the purpose of this class, I'm going to create a new pipeline, right? So I'll just, on Designer, when you go to Designer, so you can navigate to Designer on the left-hand side, and you can see the option to create a new pipeline, right? So I'll just go ahead and try to create a new pipeline. And now what we're going to be doing for this demo session is trying to create a model that predicts the price of a car, of cars, right? So basically, we're going to train our model to understand different parameters about a car, different information about a car, and based on previous experiences and how those cars are priced, the model would learn to predict the price of a car, right? So for that, this is our designer. Just for the ease of it, we're going to start creating that now. The very first thing, right, is to bring in the data that we're going to be making use of, right? So for this, I'm going to bring in um, a data set called automobile price data. So I'm just going to drag this. Remember, on Designer, is as easy as just dragging and dropping, right? So I've done this, I've dragged this to the canvas. And we did talk about exploratory data analysis, right? So if I want to see what this data set looks like, I can right click on this, and then Azure Machine Learning, the designer, gives me that option to be able to preview the data. Once I click on preview data, this it gives me a window. Let me expand this. So you can see that it gives me a view of the data that I am dealing with, right? So you can see different entries of my data. You can see the distribution, a graphical representation of how inputs are distributed, in the data, right? So the first thing I noticed here is that I'm having some null values, or some missing values rather, in this particular field called normalized losses, right? So that's one thing to notice. I have a lot of other fields. Some of them have multiple entries. Some of them have just dual entries, right? So this just gives me an idea of what I'm dealing with, right? And at the end of the day, what are we trying to predict? We're trying to predict price. So you can see price here. This is a number, right? With a quantity. And based on the conversation that we had, based on what we went through before coming to the demo environment, we did say that if we're predicting a category, we'd be using classification models. If we're predicting a quantity like price, we're going to be using regression models. So basically, we're going to be using a regression model for this exercise that we're trying to carry out. So I'm going to close this now. So maybe I don't, I'm going to close that. Then the next thing I would want to do is, based on the observation I had while carrying out my data exploration, basically what we just did when we said preview data, this is one way to carry out data exploration, right? So you're exploring the data, you're seeing different things, different occurrences, different trends within the data, right? So, but based on that, I did mention that one of my fields is having a lot of missing data, or one column rather. One column in my data is having a lot of missing data. So what I'm going to do is I'm going to try to exclude that field. That's one thing I'm going to do. So for me to exclude it, I would have to select a component that would help me do that, right? So I can switch to components now on Designer, and you can see that there. I usually prefer to have these components, arranged in order of how they are utilized, or what aspect of machine learning they are utilized for. So what I'd usually advise to do is to click on the funnel up here, and then maybe just say designer built-in assets only. What this does for me basically is to arrange all of those or group all of those components, right? So, but then a lot of the things I want to do right now is around data transformation, right? So I can expand this and maybe clean missing data. That's one thing I want to do. Also, I want to select a column. So you can see how easy it was for me to drag from left to the right, or I can even search from the search bar. So maybe I want to select, a column for my data set. So there is a component for that, right? So I can put that here. So I can drag. Remember, when building our machine learning pipeline, right? We do that by connecting multiple components to each other, right? So I can connect from my data set down to the next component by basically clicking from the input node or from the output node of the data component into the input node of the next component. And that's as easy as it gets, right? So now what do I want to do? I want to select a column. I want to exclude a particular column, right? So I can double click on this. It brings me the settings panel on the right hand side where I can configure this component. So I can say edit columns. Now, I can choose to approach this different ways, maybe using a rule. These are different rules that I can assign or I can work with, or I can do this by name, right? So let's say I am going to be doing this by name, yeah? So the first thing I want to do is to even include all of the columns that I'm going to be working with by saying add all, and then I would exclude that particular column that I want to take out, which is normalized losses, right? So I can take that out, and then I think this is all I need to do now. So if I save this, if I also want to put in some annotations so that my whoever, if I have team members that we work on this together, even when I'm not around, they would know that I left a comment here to say excluded normalized losses column, right? So, and that's as easy as it gets. So once I'm done with that, perhaps the next thing I want to do is to maybe even clean out missing data from the entire data set, right? So there are probably some other columns, some other fields, or some other variables that have missing, maybe few missing data. So I can go ahead and connect the output node of the previous component to the input node of the clean missing data component, right? So the same thing, I can also double click on this to get the setting to the right. And for me to do this, I can go ahead and say edit columns. From editing columns, which if there are 3 columns that I want to perform this operation on for cleaning out missing data, I can select those 3 columns. Maybe I want to go with the approach that I did earlier by passing all of the columns and then work on that. I can go ahead and do that. Otherwise, I can just stick to what I using the rules. I can just stick to that. So just give me a moment. Okay, so because I already used the name and then said add all, so let me just remove all and then go back to rules and then say maybe all columns, right? And then I can just go ahead and save this. So my pipeline keeps growing, right? Now the next thing I would probably want to do at this point is maybe splitting my data. I know I want to train a machine learning model, so I can go ahead and split my data into a training set and a test set. The training set is what we're going to use to train the model to make sure that the model understands different possibilities that could happen within our data and how to label those possibilities when they happen, right? So for me to split my data, I can go ahead and call the split component, right? So I can go ahead and just type split. So you can see I have a component that says split data. So I can drag this into the canvas. Now, another thing to note, after we performed the operation of cleaning missing data, you can see there are 2 outputs, or there are 2 output ports, right? You would use the one on the left-hand side. The one on the left, that is where the cleaned data comes out from. The on clean data, this is where it comes out from the left-hand side. So I'll just connect from the right-hand side into the next component, which splits my data. So for splitting my data, now different machine learning engineers or data scientists get to have preference for what to use as an ideal split, whether to split your data 70% for training set, 30% for test set, or 80% for training set, 20% for test set, right? And a good practice, is to have in mind that you need to train your data with enough observations so that it can be able to recognize possible patterns, in your data, right? Also, you'd have to take into account that you should try not to overfit your data by, using too many fields, so that it can be able to learn too many records, so it can be able to learn as ideally as possible, right? So what we can do in our case is to maybe do a 70%, 30% split. 70%, 30% split would work for us. Now, for me to do a 70%, 30%, you can see from the settings panel on the right-hand side, this is asking me fraction of rows in the first output data set. So if you look at the split data component, you can see it also has 2 ports. Now, what that means is that when you split the data, one part of the split would come out from one port, the other part of the split would come out from the other port. That's basically how it's gonna work. So I want to split this into a 70 to 30% ratio, right? So for 70, I'll just say 0.7. If I wanted to do 80, I would say 0.8. If I wanted to do 75 to 25, I would say 0.75. But I want to stick to 70%, so I will do 0.7. Now, another thing to note is, do I want this to split the data randomly or sequentially? So, for instance, imagine you have 200 records, right? And the record is collecting data between the male gender and the female gender. And the first 130 records are data relating to male gender, right? In that case, if I split sequentially, then it's going to take the first 70% of that data, which a lot of them would even be, if not all of them, would even be in the male category, right? And then my model would not know what to do if it encounters a female record, right? So for me to ensure that it doesn't do that, it randomize how it selects that 70%, I would make sure that randomized split is set to true, right? Another key thing to note, so let's say I also have a colleague in the UK that wants to replicate what I am doing right now and achieve the same result using the same data set, right? Now, I can put a seed to my split, so that the way I am splitting, that is the way my colleague in the UK would also have his data splitted if we provide the same seed. So let's say I provide a seed as 1, 2, 3. When my colleague is splitting his data on his own end, he's also going to impute 1, 2, 3, so that it would give him the same exact split that it used for me. Despite the fact that it is using a random split, it is also going to split in the same random manner for the both of us. Okay, so now stratified split also is something, these are some statistical terms, right? But also what it does is just to make sure that your training set is a represent. Okay, so when you split your training set and you split your if you split your data into training and test set, the representation of your training data would also be the representation of your test data. So if I have within my training data, 60% of it is for a category A and 20%, the other 40% is of a category B, that is still the same way is going to happen for my test set, right? So, but just not to dwell on that because we're pressed for time. So we're splitting the data here. Then the next thing is we did talk about selecting a model, right? And we've looked at the problem we're trying to solve. We're trying to predict the price of a house, sorry, of a car, right? Quantity, we're trying to predict quantity. So it's a regression kind of problem. So what that means is that I'm going to use a regression model for this particular problem. So what I can do here in Azure Machine Learning, so let me go to on the left-hand side, you can see model training. There's a category here called model training. When you expand this, you can see there is one component here that is called train model, right? So I can drag this to the canvas. Now you see this model, this component, look at the input nodes. You can see the first part of the input node. Let me see if I can expand this. So it would just, okay, yes. Now, if you look at this, the left-hand side, you can see what is expecting as an input, right? It's expecting an untrained model. Now, on the right-hand side is expecting a data set, right? So this is just where the training would happen. But I need to bring in the model that I want to use or that I want to train. So if I also go back to the left-hand side, and then if you look up here, you would see machine learning algorithms, right? So these are the different algorithms or different models that I can train in order to achieve my purpose. But for this case, I'll just use a linear regression model. I'll use a linear regression model. I'm dragging this to the canvas. Now I want to connect my model and my data set to this train model component, right? So this is my data set on the left-hand side. This is my model on the right. Sorry, my data set is on the right-hand side. My model is on the left-hand side. So I can drag from the input port of my linear regression model into the untrained model port. Now that connects my model, to this train model component. Now the training data, remember what we are doing right now is we want to train a model. Now the data set between the 70% and 30% split of our data, the one that we're going to be using for training our data is the larger portion, the 70% portion, right? So I did mention that when you're splitting the output, you can see we have two ports. Let me also see if I can expand this a little bit. So you can see result data set 1, result data set 2. And if you remember when we typed in 0.7, it said fraction of rows in the first output data set, that's result data set 1. And we said we wanted it to be 70% of our data. So that means in this first port, 70% of our data lies in here. So I can drag that into the dataset port of our train model component, right? So now what that means is that our model is now connected, or our model is now connected to where it's going to be trained. Now, for it to be trained, it needs to know what exactly I am trying to predict. Remember my training data set, I have the different observations and their labels, the outcome, what I'm trying to predict. I have it already in the training data set, right? So I need to point to my model to say, this is what I'm trying to predict. Know it, look at the other fields, other variables, other parameters that I'm passing in with respect to my data.
5 minutes.
Oh, great, great. Yeah, I can see it. So I will just go ahead and click on edit column. I'll go ahead and click on edit columns. And then I need to specify the column that I am trying to predict. Now, the column that I'm trying to predict is called prices, right? So if I go ahead and if I wanted to type, I could go ahead and type. But if I want to select, or it's called price, if I want to select, I can come here and select it. But take note, if you're typing, make sure that it is in lowercase, or make sure that it is represented the same way it is captured. So I'm just going to go ahead and select this real quick because we're out of time. I'll save this. Now, what's it called now? I'm sure we'd also get to look at other areas, in other sessions, like using automated machine learning, automated ML, right? Then at that point, you're probably going to understand more about model explanation. So, but it just tells you when you're using multiple models, it gives you an explanation why it categorizes one model to be better than the other. Okay, so now we've done this. The next thing, we did say that after training our model, we need to evaluate our model. So I'm going to quickly look for evaluate. So I can go ahead and evaluate. But at the same time, before I evaluate, I need to score the model. I need to score the model. So I go ahead and look for score. Great. So for scoring the model, now we've trained the model, right? We've trained the model in here, and then we want to use the test data set to score the model so that we can be able to evaluate the performance of the model. So what that means is that I can pass my trained model from the output of this trained model component. I can pass that trained model into this other input that expects a trained model. And then for the test data sets that I'm going to use here, I would connect from result data set 2 from my split data. I can connect from that into this particular node, right? So once I do that, this is where the score of my model is going to happen to make sure that my to tell me how my model, is faring. I can connect that to, my evaluate model component as well. And then let's just so that we are sure that everything is as it should be, we can go ahead and easily validate to see if there is anything that we've not set. Now, you see on the left-hand side, it says select compute target in setting panel. So at the very first instance, we're supposed to even select what compute that we want to use for this entire process. So I can go to settings and I would select my compute. I'll select my compute. Once that is done, if we validate again, you'd see that we're good to go, right? Now, this is end to end what we've been able to build, with respect to our model. And then we can now submit this to be executed as an experiment, right? So you'd execute this, is going to run every step one after the other. And so just quickly do this. I would use an existing experiment that I have. If you do not have an existing experiment, you can choose to create a new one. And I'll just leave the other information the way they are and just submit, right? So this is just going to take a little bit of time, submit the model, and begin to run it. So on the left-hand side, you would see the results, or you would see the status of whether the job has been submitted or not. Just give it a moment. So I don't know if okay. So while that is happening, the other thing that we would get to do, the model is running. We can go and monitor the model and see how the model is performing, right? But another key thing that we need to do is to deploy this model so that the different business processes that we've built that want to utilize this model can be able to connect to the model and consume it. Right. So for that, before we get to do that, let's look at the job execution that is already running. I know we're really out of time right now, so I will just showcase this. So you can see the model is currently running, right? So you can see this is the components that is running at the moment, but it's going to process everything one after the other. And so long as everything is the way it should be, they should all be green, just like this particular component is, right? And that's basically how we get to build, our model using Azure Machine Learning Designer. Like I said, if we were to go in depth into a whole lot of things around building a model, deploying a model, it's going to take us, a bit of time. But for I think the only thing that I have not shown is how to, deploy this model to production. And to do that is simply clicking a button. By the time this model is done running, at the top, somewhere at the top where my cursor is, you should see infer pipeline, right? So basically, once you click on that, it's going to deploy the model into a production state. That way, different business processes or whatever you want to utilize the model for, you can be able to connect to the endpoint that is generated at that for this particular model. For the benefit of time, I will just leave it at this. And I don't know if there are questions. Mr. Rashid, I don't know if we have any questions so far from the audience before we wrap this up.
Okay. Thank you so much, Mr. Emmanuel. This is loaded. Thank you so much. For now, we don't have any question. But before I go on, I need to please appeal to us to please fill our feedback form. We really need your feedback. How do you see the session? As the facilitator has he been able to impact knowledge? For me, I learn a lot. I've always, I'm aspiring data scientist person, and this machine learning of a thing is a very big deal for me. But the way Mr. Emmanuel is able to trash it down today is very, very amazing. And I just want to say thank you. Personally, I want to say thank you. At least I can see the way you are navigating the whole process. I mean, one after the other. They are so you make it look so easy, but I know that it goes beyond that. I can't predict how much midnight oil you have burnt to achieve all this. So thank you so much, and we appreciate your session sincerely. Also, as we speak, I don't have any question. So, which means it's either all that you have taught us is well understood, or we are terribly confused. It has to be two things. But for me,
Yeah,
I'm not
I hope
confused
the
really.
former is the case, right? I hope the
For
former
me,
is the case.
I'm not confused really. For me, I'm not confused. It's just for me to go back to the drawing board and see how I can build on this foundation that you have laid today on machine learning model, building a machine learning, building a machine learning model and building a machine learning model on Azure. I mean, your demo session is very, very amazing. Thank you so much. I'll still need to go and watch the video again. So, and that's what we can do for everyone that is on this call. We need to explore this thing. We need to watch it over and over again. When you see a presenter coming on board, talking and talking confidently, go and interview the presenter, so you know what he has done behind the scene. So it's a continuous learning process, and so this is how we are going to end today's session. I want to say a very big thank you to Mr. Emmanuel Eze for this session. It's very value adding, very expository, and you just took the topics one after the other. For me, I'm really blessed, and it's worth my time. So this is how we are going to end today's broadcast. See you same time, next week. We have two sessions, one from 3 to 4, another one from 4 to 5. Thank you so much. And Mr. Manuel, we thank you. We would love to see you very soon again, because this is your session for me. I have to download it and watch and over again. So thank you, everyone. Thank you for all our viewers, and let us have an amazing weekend. Thank you. Bye bye.
Thank you, Rashid, and bye bye, everyone. Thank you.